Welcome back, learners. So as you move on to now the next set of questions, which are the application questions, and they are still based on static electricity and friction. The first question is on those application questions. We need to look at the picture of hair and a comb, and we need to answer the questions that follow. We can see that we have a picture of hair and comb, and then the electrons are transferred from the hair into the comb. So with this in mind, let's then answer the questions that are following. The first question says, which object gave up or which object transferred some of its electrons? So we can see from the picture that the hair is transferring its electrons into the comb. So therefore, which object transferred some of its electrons? It was the hair. The hair transferred some of its electrons. Now, the following question says, does now this object have more positive or more negative charges? So if a substance transfers its electrons to the other substance, then obviously that substance that transferred its electrons will remain with more positives than the negatives. So what does it mean? The object will have more positive than negative charges. So does this object now have more positive or more negative charges? It will have more positive charges. So if we are starting from a neutral substance, where the comb being neutrally charged and the hair also being neutrally charged, should now the hair transfer its charges, its negative charges or the electrons to the comb, then the hair will now remain with more positives than the negatives. So therefore the hair will be more positive. Now the comb, by gaining or by receiving those electrons from the hair, it will have now more electrons, which will translate to more negative charges than the positive charges, if we are starting from a neutrally charged comb. So question C says, which object gained electrons in the diagram? So if the hair transferred its electrons to the comb, then obviously the comb gained the electrons. So the comb gained the electrons. So this comb that you're talking about here, does it now have more positive or does it now have more negative charges? So it gaining the electrons, meaning that it now has more negative charges. And the one that transferred the electrons will remain with more positive charges. So the comb will have more negative charges. The comb will have more negative charges. So the following question now, we need to look at the images in the table. Which images are they referring to? These two images. So we need to look at these images and redraw the images to show how the spheres will move because of the nature of the charges. And we also need to write down an explanation for our drawing. So as we start with our first image, we have two spheres that are oppositely charged. One is negative and the other one is positive. So now, how will those two spheres move because of the nature of the charges? According to the law of electric charge, it states that the like charges are going to repel each other and unlike charges are going to attract each other. And attract means moving closer towards the other substance. So that means the negative sphere is going to be attracted to the positive sphere. So they will move closer to each other. Why? Because unlike charges attract. So the reason why these two spheres move closer to each other, because unlike charges attract. Now our next spheres that we have here, they are both positively charged. Them being both positively charged, according to the law, like charges repel and unlike charges attract. These two that we have here, they are like charges. So that means they're going to be moving away from each other. So that means the first one will be going to the other side and the other one will be going to the other side. So which then means they will be, that means they will be moving away from each other. So this is going to be going that side and the other one going that side because they are both positive. So the same thing is true if those two charges were negative. So if those two charges were both negative, the two charges will still be moving away from each other. So them both being positive and both being negative means that they are going to repel each other and moving away from each other. So why do we say they are going to be moving away from each other? Because like charges repel. So unlike charges attract each other and like charges repel each other. Both negative charges will repel each other and both positive charges will also repel each other. So moving on to the next part of the question. It says, the ruler in this photo has been rubbed with a cloth. So remember, rubbing a substance with another one, that's what you call friction. So they have rubbed a ruler with a cloth, and we need to describe what is happening in this photo and why does this happen. So we can see that that ruler will attract the pieces of paper that are on the table. So why does this happen, or what is happening here and why does it happen? So firstly, we know that the cloth will transfer the electrons to the ruler. So as they are rubbing each other, there's going to be friction. And during that friction, the cloth is going to transfer its electrons to the ruler. And because of that, the ruler will then be negatively charged, or will have more negative charges that are going to be on it. So therefore, the overall charge of the ruler is going to be negative. So remember that the pieces of paper are neutral, and they will be attracted to the ruler because when the pieces of paper are brought closer to the ruler, the charges in the pieces of paper are going to be separated. Now, let's visualize this. We have equal number of protons and equal number of electrons. Once I bring closer a ruler next to the pieces of paper, which is negatively charged, it is going to repel the electrons on the pieces of paper, which then will attract the positive charges towards the ruler. So therefore, the pieces of paper are going to be attracted towards the ruler, and in that scenario, those electrons are going to be pushed to the other edge of the piece of paper, but they will still be within the piece of a paper. Next question. Question 4 says, sometimes when you are pushing a trolley, you can get a small shock. So whenever you're there at the shops or somewhere, you're doing your shopping with your parents and you're pushing the trolley, sometimes you can get a small shock. We need to now explain why this would happen. So the next time when this happens to you, you can explain to an adult that is next to you why that happened to you or why that is happening to you. So firstly, we know that friction, that's now the rubbing of two materials together. So in this case, the friction between the floor and the trolley causes the buildup of charges on the trolley. So the trolley will now have more charges, more negative charges. And then the charges are going to be earthed. Remember what earthing is? We talked about earthing. The charges are going to be earthed by you, by your body. So your body is going to be earthing those charges, which will then cause a shock. So that earthing of the charges by your body will cause that shock that you're going to be feeling as you're pushing that trolley in the supermarket or anywhere when you're doing your shopping. So the next question that we have here, it says, why does your jersey make a crackling sound when you pull it over your head? So whenever you're taking off your jersey, why does your jersey make that crackling sound whenever you're pulling it over your head? So we need to know the following things, why this happens. Number one, when you pull the jersey over your head, the friction now between the jersey and your hair causes the jersey and your hair to become charged. Remember, initially the jersey is neutral, and also the hair is also neutral. So when they are rubbing against each other, that friction is going to cause both the jersey and the hair to be electrically charged. And when this happens, the movement of electrons from your hair releases energy. So as the electrons are going to be transferred from your hair to the jersey, energy is going to be released. And then that energy is released in a form of light and sound. So the sound, it is that crackling sound that you hear, and the light, it's that spark that you see whenever you're trying to take off your jersey. Whenever you're trying to even wear your jersey, that sound, it's that crackling sound that you hear, and the light, it is that spark that you see when electrons are being transferred from your hair into the jersey. So that is the explanation of why your jersey makes a crackling sound when you pull it over your head. So with that said, we're just going to go for a quick short break, and I will see you just after the short break.